You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
You gotta love how they categorize rockets. Small, medium lift, heavy, and super heavy. Quite self-explanatory, really. Anyone who has seen a rocket launch will tell you that they're all amazing to see. But there's something about 33 rocket engines ignited all at once that has us space nerds in a tizzy. Super heavy Starship. Wow. Just wow.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger roll.
Today is November 20th, 2023. I'm Maria Varmazis, and this is T-minus. SpaceX's Starship launched for its second test flight. Ursa Major unveils a new solid rocket motor. Blackshark.ai closes an oversubscribed Series A funding round. And our guest today is Princeton University researcher and educator Mike Galvin. Let's take a look at our intel briefing for this Monday. And we couldn't start our intelligence briefing today without mentioning Starship, of course. The most powerful rocket ever flown. Took off without a hitch. Not an easy feat if you remember what happened back in April. Water deluge system, successful. Pad seams intact? Check. On to separation, and again, success. And then things went a little awry. The booster dropped and for a quick second seemed to be heading back as planned. But then, RUD. That's a rapid, unplanned disassembly. Not the end of the flight, though, and not the end of the road at all for launch. Starship flew for more than 7 minutes before it lost connection with the control room. Thank goodness for the success of the flight termination system, which automatically deployed. Yep, so that's 2 RUDs, but don't despair. There were so many milestones that it did reach that SpaceX is hailing the test flight number 2 as an overall success. It's a sentiment that NASA Administrator Bill Nelson agrees with, saying, "Spaceflight is a bold adventure demanding a can-do spirit and daring innovation. Today's test is an opportunity to learn, then fly again." Cue the Federal Aviation Administration, who were quick to release the following statement. A mishap occurred during the SpaceX Starship OFT-2 launch from Boca Chica, Texas on Saturday, November 18th. The anomaly resulted in the loss of the vehicle. No injuries or public property damage have been reported. The FAA, as you might expect, will be involved in every step of the mishap investigation process and must approve the final mishap report, including any corrective actions. A return to flight of the Starship Super Heavy vehicle is based on the FAA determining that any system, process, or procedure related to the mishap does not affect public safety. You gotta love those safety nerds. It may be a little while until we see the Super Heavy back in action, but I think the folks at SpaceX are patting themselves on the back and are back in the workshops completing the next version as we speak, in hopes that flight number 3 is ready ahead of the conclusion of that FAA investigation. And until then, we will return to our normal state of anticipation for the next Starship flight. And speaking of SpaceX and NASA, the agency's Assistant Deputy Associate Administrator in NASA's Moon to Mars Program Office said that SpaceX will have to perform Starship launches from both its current pad in Texas and one it is constructing at the Kennedy Space Center in order to send a lander to the moon for Artemis 3. Lakeisha Hawkins also said that the use of the vehicle for Artemis lunar landings will require, and I quote, in the high teens of launches, a much higher number than what the company's leadership has previously claimed. After Saturday's Starship test flight, all numbers and deadlines remain up in the air for future Artemis missions. After all, a lot depends on when the FAA mishap investigation concludes, allowing SpaceX to return Starship to regular test flights. And speaking of SpaceX and launch cadence, the company's Falcon 9 carried another 22 Starlink satellites to low Earth orbit from California this morning. It was the 55th dedicated Starlink delivery mission of the year. Even a Starship mishap does not cause a ripple to the company's ability to get into space regularly. But as we mentioned last week, with the good comes the bad with SpaceX. The Reuters report on worker injuries at SpaceX has spurred U.S. lawmakers to urge further scrutiny. California Representative Zoe Lofgren, the top Democrat on the House of Representatives Science, Space, and Technology Committee, said the report's findings were, quote, deeply concerning and must be taken very seriously. The committee oversees NASA's budget and the activities of the agency's contractors. NASA has paid SpaceX $11.8 billion to date as a private space contractor. No news yet on whether that report will cause delays to their launch calendar, but I'm sure we'll know more after this week's break. Now on to something that isn't SpaceX related. Rocket motor company Ursa Major has released a new solid rocket motor, or SRM, that they're calling Lynx. Ursa Major says Lynx offers a faster, more affordable process, leveraging 3D printing to manufacture multiple motors that promise to outperform legacy systems. Ursa Major founder and CEO Joe Larienti said in the press release that Lynx meets the defense industry's need for a faster, cheaper, scalable, and flexible production process that results in better performing solid rocket motors. We've adapted our extensive experience in additive manufacturing, materials development, and propulsion production to the most pressing problems that face the SRM industry. The result is an adaptable manufacturing process that is designed to mass produce multiple systems, rapidly switching from one model to another, producing reliable SRMs quickly and at scale, while leaving room to collaborate across the industry on energetics. And you can hear more about Ursa Major by listening back to episode 112 of our show that featured a chat with the company's co-founder and EVP of Product Engineering, Bill Murray. We've included a link to that episode in our show notes for you. AI geospatial intelligence company Blackshark.ai closed an oversubscribed Series A funding round. After an extension, the company raised a total of $35 million to support its 3D mapping geospatial intelligence capabilities. Blackshark.ai's geospatial platform extracts insights about the planet's infrastructure from current satellite and aerial imagery via machine learning at global scale. The Austria-based company says the funding will be allocated to support strategic technology developments and to bolster Blackshark.ai's sales and marketing activities. NASA has reportedly told the UK government that a British astronaut could walk on the moon as early as 2025. Michelle Donnellan, the UK Science Secretary, said it was, quote, only a matter of time until we get a British person on the moon. The announcement suggests that NASA is considering international partners for its first manned mission to the moon since 1972. Artemis 3, after all, is tentatively scheduled for launch in 2025, although NASA has already admitted that it's likely to slip to 2026. The China Manned Space Agency has announced 4 missions to the Tiangong space station in 2024. The agency announced that the Tianzhou 7 cargo spacecraft is out of the factory and has been transported to its launch site in South China's Hainan province and is due to launch the first resupply mission to the station early next year. A second resupply mission was also announced, along with 2 manned missions to the Chinese space station expected in the 12-month period. The United Arab Emirates is working to grow its space sector. The UAE has established an economic zone which has already attracted 14 companies, with 10 of them owned by Emirati nationals. These space startups offer critical services, including satellite-based wildlife tracking and solutions for data center security. The UAE Space Agency says it is committed to fostering a robust private sector within its space industry to ensure that space activities contribute significantly to the national economy. And that concludes our briefing for today. We have included links to further reading on all the headlines we've mentioned in our show notes. And as always, we've included a few extras for you. One's on Europe's space program playing catch-up, a piece on why space-based weather monitoring is crucial for the military, and a third one on Mr. Musk again and his future Mars colony, providing a base for asteroid miners. They're all at space.n2k.com, and just click on this podcast title. Hey T-Minus crew, every Monday we produce a written intelligence roundup. It's called Signals and Space. So if you happen to miss any T-Minus episodes, this strategic intelligence product will get you up to speed in the fastest way possible. It's all signal, no noise. You can sign up for Signals in Space in our show notes or at space.n2k.com.
And now a word from our sponsor, 6 Sense. 6 Sense provides award-winning cloud-based automated endpoint and vulnerability management solutions to streamline IT and security operations. With its advanced platform, businesses gain complete visibility and control over their infrastructure, reducing IT and security risks and optimizing operational efficiency. With 6 Sense, you'll get real-time alerts, risk-based vulnerability prioritization and remediations, and an intuitive automation and orchestration engine so you can focus on your core business goals, confident in the knowledge that your enterprise is secure, compliant, and running smoothly. Visit 6sense.com to learn why enterprises choose them.
Our guest today is Princeton University researcher and educator Mike Galvin. And I caught up with Mike at the Main Space Conference earlier this month to discuss his STEM outreach program with MaxIQ.
I'm a half research engineer, half educator at Princeton University. On the research side, I do mechanical design for more like NASA flagship missions, spaceflight hardware, instrumentation, different space hardware for like more flagship class missions. And then on the teaching side, I'm the principal investigator for our student CubeSat group. We're interested in all kinds of nanosatellites, but we're primarily a CubeSat group, helping our undergrads design real satellites and real spacecraft. They're tiny, but they're real spacecraft to go into real orbits and do real missions.
And on undergraduate level, that's amazing to have that opportunity.
That's right. It's. I mean, we're at this weird point in time where it has become quite accessible for student groups to reasonably expect that they can design, build, and launch a real spacecraft into orbit in a few years, usually.
Amazing.
But that's a crazy thing to think about, that students can launch spacecraft now.
Yeah, admittedly, that blows my mind a little bit. So, tell me about how you've been working with MaxIQ to make this happen.
So we first started collaborating with MaxIQ when we were participants in the ThinSat program, which was a STEM launch program for schools run out of Virginia. It was the Virginia Space Grant. And MaxIQ provided a bunch of these electronics sensor kits, click together, no soldering sensor kits that could integrate into small slice of bread sized satellites. And that's how we got our Princeton's first student satellites into orbit. We launched 2 ThinSats into a low Earth orbit for about a week. And these kits are kind of the easy button option to help schools get their first project into orbit because they have spaceflight heritage. They've survived space. They've survived orbit. They're really easy to work with and click together without doing much soldering. And they provide a really nice opportunity to learn coding and software engineering for programming readout software to read out the different sensor values that you're interested in on orbit.
So what kind of tests and what kind of sensors are students generally using? Like, what are they doing?
There's a variety of sensors, the whole ecosystem of sensors, but maybe the core ones are like an inertial measurement unit, which is a suite of accelerometers and gyroscopes and magnetometers to sort of do sensor fusion to figure out your orientation in orbit and your pointing and your accelerations. There's light sensors, there's UV sensors, there's IR sensors, there's imagers. There are weather sensors, so you can measure pressure drop during ascent. That can work as an indirect altimeter. So there's a lot of different sensors. But my student group is mostly mechanical engineers. So we're in the mechanical engineering department. And so we're less interested in the electronics and the coding. And we're more interested in the mechanical packaging that can package and batch these kits into immediately launchable form factors and platforms. So we're less interested in getting the chips on orbit than we are in getting our mechanics on orbit.
Yeah.
And we've been trying to find all different reliable ways to get, batched schools, like a bunch of schools into space at once for the first time. And one of the best ideas we had is to package these kits to batch these kits into a 1U CubeSat, which is the original CubeSat, standard size 10 centimeter by 10 centimeter by 10 centimeter cube. And we can replace the usual solar panels with these kits because we're interested in ultra short missions on the 1 week time scale where they burn up within a week. They don't clutter low Earth orbit. They provide no orbital debris, but
very important
full end-to-end experience of designing space qualified hardware and downlinking data from dozens of orbits in the span of a week, proving survivability in orbit, and even operating your satellite from the ground. You get all of that in a week, and you have to survive a launch, which is challenging in itself.
Absolutely.
But we're not cluttering up low Earth orbit. So the point of that is we don't need to be collecting a lot of power to survive a week. We can charge a big battery, and we can power all the kits for a week without much solar collection. So we can repanel the whole CubeSat with a bunch of batched school kits. But even this is quite risky because getting a 1U CubeSat to survive orbit and downlink reliably
tough.
Is still a crapshoot these days for schools. So we started thinking about what's even simpler, what's an easier way to get all these kits in space, in a real orbit, so we can have a real educational space program. And it's not just a ground program. And so that's where this project fits in.
Okay.
We tried to figure out what's the most reliable, frequent ride to space. And that is, at the moment, as long as we can convince Congress to keep the International Space Station in orbit for a few more years, resupply shuttles back and forth to the International Space Station is the most reliable game in town for getting frequent access to low Earth orbit. And there are some launch and experiment integrators for the International Space Station. One of the oldest and most successful ones is NanoRacks.
Yep.
Nanorex makes these nanode drawer units that can package what they call nanolabs, which are basically just off-the-shelf boxes from them that provide power and data links. And basically, the nanolabs are pre-qualified for launch. So as long as you can responsibly fit something into the box and seal it up, it's considered safe for launch, and you're ready to go. So we took some of the Max IQ kits, and we shrunk them down just a few millimeters to the point that they could slide right into the nanolab. And we figured out how to stack 10 to 20 kits in one nanolab and break them out to route them out to power and signal lines to the nanode. And we can launch them. They launch typically with a supply mission or even with the astronaut shuttles. They get a very gentle ride up to LEO. They're usually packed in like quasi bubble wrap, so they don't suffer a very violent launch. The nano drawer gets slid into these racks that they already have pre-existing, dozens of these racks already pre-existing in the ISS modules, and they can operate unattended for months at a time. We are interested in just simply asking the astronauts to reboot them every few weeks, just in case anything latches up. We can make sure all the schools stay alive and get some data, because we'll just reboot them a few times. And then after a few months of data collection, each school has their own flight computer. So we're not using a single flight computer. Each school in the stack has their own flight computer. They have to write their own software for their own mission to read out which sensors they're interested in at the frequency that they're interested in. And while they're using off-the-shelf kits, they get to send a little piece of themselves to space in the fact that it's their own custom handwritten software. And what we're really excited about, another angle of the ISS platform, is after a few months of data collection, we can actually retrieve the hardware. It can come back down on one of the astronaut shuttles, and we can send the kits back to the different schools. And I mean, this is just my personal idea, is we can hand out individual chips as awards to the best students or the best student groups participating in our STEM programs. And then everybody gets to take home, a little chip that went to real low Earth orbit, was handled by the real ISS astronauts.
That's amazing.
And they get that as a souvenir of the STEM program. And the whole goal here is, how do we do a launch every school year? We start a curriculum at the beginning of the school year. We teach the electronics kits. We teach space qualification. We teach design for launch, design for space. And we get them through, teach them coding.
And again, these are undergrads, right?
Undergrads. A lot of high schools are using these kits. In particular, here in Maine, they've rolled out these kits to a bunch of high schools who are having a great experience with them.
That's amazing.
And they're totally capable of learning Arduino code, C code, Python language to program these kits. And we found that the real motivational thing is to roll out the curriculum, but also have the carrot of a guaranteed launch at the end of the school year, reliably, every year. And that's sort of the holy grail we're going for with this ISS framework.
We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
Welcome back. And do you remember some months ago we told you about the naming competition for the upcoming Australian lunar rover? The competition was open to all suggestions from the start of September through about the end of October. And yeah, I bet there were a bunch of Rover McRover faces in the list. Be honest, how many of you wrote that one in? Well, as of today, the short list of 4 names picked of the over 8,000 submitted is out. Sorry to say, Rover McRoverface wasn't one of them. Yeah, I know, big bummer. But the top 4 contenders are these. Number 1, Coolaman. Capturing the essence of our indigenous heritage and connection to the land, a Coolaman is a multi-purpose, sustainable tool used for gathering and carrying. It symbolizes the balance between utility and respect for the environment, mirroring our approach to space exploration. Number 2, Kakira. Translated from the Kaurna region in Adelaide, Kakira means moon and is a tribute to the history of Australia, just as the rover is about the future of this country. The rover is very important to lunar expeditions and is a big step for Australia. Number 3, mateship. From the spirit of the Anzacs to your mate at the local footy club, it's a crucial part of the Australian culture. I apologize for reading this in an American accent. I'm really not selling it, but just pretend that I'm reading it as an Australian. Whether you're young or old, live in the city or in the outback, we all possess this indescribable trait. Let's say g'day, mate, to new horizons and the lunar surface. And number 4, Rover. Our lunar rover deserves to be named after something iconically Australian, reflecting the Aussie spirit as we launch into this new endeavor. A kangaroo is part of the Australian coat of arms, and it's time for Australian science to take the next leap all the way up into space. Okay, sorry everybody. What's your favorite? Personally, I'm kind of partial to Kakira, but Rover definitely has some fans pulling for it here at T-. Whatever your pref, you've only got until December 1st to vote, and we'll put the voting link in the show notes for you. And we'll find out the winning name for the Australian lunar rover on December 6th. That's it for T- for November 20th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. We're privileged that N2K and podcasts like T- are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. Learn more at n2k.com. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. And I'm Maria Varmazis. Thanks so much for listening. We'll see you tomorrow.